Okay, so the last, I think there are two examples here. I think. So the last two examples here, I have titled like multiple choice common questions, and it's just questions that seem to come up very frequently, and it may not even be multiple choice. It could be a part of a free response, but it just seems to come up so often. So I wanted to do these. And the first one I like for number 10 is that it's a bit deceiving what the outer function is. Sine squared of 3 theta. Even the way you read it, sine as being the first function you read, sometimes you think that's the outer function. Like when you read square root, the square root of, and it's the square root that's the outer function, right? Or so sine squared, you might think sine's the outer function, but it's really not. And it has to do with the fact that that square is really what that problem is really squaring is the sine itself. So you could rewrite that's sine of 3 theta as a whole quantity squared. That square on the outside is actually your outer function. So like I said, I like asking this question, and I think the AP exam asks a lot too, simply for the fact that it is deceiving how, it's deceiving, what is that, what is that outer function truly? So I think what I'll do is I'll make a bigger dot. So pen, black, and then here we go. So just again to kind of black that out there, even though you could. Oh yeah, no, it's blacked out. Good. So then what is the derivative of anything squared? Well, it's 2 times that thing to the first power. So when I do the derivative, go back to red here. So f prime of theta, it's a quadratic, so it's 2 times that thing to the first power. Now, what was that thing? Again, still needing practice. So there it is, sine of 3 theta. So then I'll go ahead and write sine of 3 theta. But now sine of 3 theta needs a derivative as well. So sine of 3 theta's derivative is cosine of 3 theta. But again, the derivative of sine is cosine, but you have to remember that it doesn't matter what's inside here, right? The derivative of sine is going to be cosine of that thing. So I'm going to try very carefully to try to pull that thing out. Oh, look at that. So then cosine of that thing here, and what is that thing's derivative? Oh, well, it's going to be 3. So there are 3 chains here, or 3 pieces to this, because there was the quadratic, there's the sine, and then there's the triple, or the 3 linear function as a coefficient. So then collecting this all together, 3 times 2 is 6, and then sine 3 theta, cosine 3 theta. Now, initially, you might feel like you haven't taken enough derivatives, or like you want to keep doing chain forever and ever and ever, but it's only 1. Like for example, let's say your function was y equals 3x cubed plus 1 to the 5th power. Okay, so then you'd say, okay, dy dx is equal to, the 5 comes down, so it's 5 times that thing to the 4th power, then chain rule. So what's the derivative of this? That's 9x squared, and that's it. It's a one and done thing. But when we first learn chain rule, students sometimes want to continue just doing it almost like a factorial. Well, the derivative of that is 18x, and the derivative of that is 18, right? No, you don't do that. You don't continue till you get to a constant. You just do it once, and you're done. Okay, so then there's your answer right there. Okay, now if you recognize there might be some kind of double angle, half angle, product, sum, whatever, awesome. Do you have to? Not at all. Okay, so one more. I think this is the last one for our notes for today. So the thing I like about this is that it's independent again of the function. It is based on the structure of chain rule. So kind of block that out, right? So now what is dy dx? So dy dx, if I go to my pen here and go thin, is f prime of that thing. And what was that thing? So we kind of reveal, hey, got it the first time. That's awesome. That's great. So that's 6x squared. But then the derivative of 6x squared, chain rule, is 12x. So dy dx is 12x times f prime of 6x squared. So that's dy dx. But now it says find the second derivative. And you're going to have to notice and realize that that's a product rule. I've got the function 12x and I've got the function f prime of 6x squared. Then within that derivative is a chain. So again, follow the structure of product rule, but then apply chain rule as necessary. So let's do the first function. So the derivative of 12x, so if I do the second derivative of y with respect to x twice. So derivative of 12x is 12, and then we leave f prime of 6x squared alone. No chain rule needed. Didn't do its derivative. Plus, leave 12x alone. Again, no chain rule because there's no derivative. Times, and then, so now I've got, I should probably use another black dot here. So now I have this thing right here. So the derivative of f prime is f double prime. So I can write that down. So f double prime of whatever's inside. And then again, check what was inside. That thing inside, aha, it was 6x squared. Can't change the identity, right? You can't do a derivative within that. So 6x squared. But then immediately afterward, what is the derivative of 6x squared? It's another 12x. So if I were to simplify this, I have 12 times f prime of 6x squared plus 12x times 12x is 144x squared times f double prime of 6x squared. So that would be the second derivative of y with respect to x twice. And again, it's really getting at the structure and the algorithm of chain rule. Okay, so I'm hoping that makes sense. And, go back and rewatch the videos and try the homework, see Canvas for the solutions, and then we'll go over questions, tomorrow. So, okay, very nice.